Good day, everyone. Today, I will be presenting my research titled Factors Influencing Restaurant Ratings on Online Food Delivery Platforms, a Machine Learning Approach. Let's start with a brief overview of my research and its findings. This research utilized correlation analysis and feature importance analysis to analyze customer reviews and delivery personnel data and identified key factors that influence restaurant ratings, which were issue type and estimated delivery time. Besides that, random forest machine learning model was chosen to predict restaurant ratings on an online food delivery platform in Malaysia, empowering them to proactively improve service and customer experiences. First and foremost, what is the problem being solved in this research? Malaysia's online food delivery market is booming, and restaurant ratings play a critical role in both platforms and customer satisfaction. But how much do factors beyond food influence them? Existing research often focuses on isolated elements like food quality and service quality. By neglecting how these factors interplay, platforms struggle to optimize services and address customer concerns effectively. Thus, this study bridges this gap by using analytical methods and machine learning to analyze a broader range of factors impacting restaurant ratings such as delivery zone, delivery fee, and delivery time. This empowers platforms to refine operations and gain a competitive edge. This research tackles research objectives focusing on three key areas. The first area is delivery zones. The objective is to determine if delivery zones in Malaysia impact restaurant ratings and user complaints. Understanding these variations can help platforms tailor their services effectively. The second area is key factors influencing restaurant ratings. The objective is to identify the critical factors shaping a customer's online food delivery experience. The third area is machine learning. The objective is to develop a machine learning model that accurately predicts restaurant ratings as positive, which is equal to or more than 4 stars, or negative, which is less than 4 stars, based on the previously identified key factors. The research objectives were achieved by employing a 5-step research methodology framework. The first step was data extraction and collection. Restaurant rating dataset, which consists of 250 customer reviews, was extracted from the Foodpanda website through web scraping to understand customer perspectives. Delivery personnel rating dataset, where 108 responses from delivery personnel were collected through an online survey to capture rider perspectives on restaurant ratings. The dataset went through data pre-processing and data transformation steps. The raw data was cleaned, where the duplicates were removed and missing information was addressed using Microsoft Excel. Next, data segmentation and feature engineering were performed. The customer comments were categorized by issue type, either restaurant issue, delivery issue, or no issue. Besides, the delivery distances were grouped into distinct delivery zones to identify potential patterns. Additionally, new metrics like estimated delivery time and rider satisfaction ratings were created for a more comprehensive analysis. And finally, for machine learning analysis, categorical variables were encoded and numerical features were standardized to ensure uniformity in all machine learning models. Once the data was ready, two types of predictor selection methods were employed to identify the factors that significantly impact restaurant ratings. The first method was correlation analysis. The correlation matrix and correlation heat map were used to assess and visualize how strongly each predictor variable is related to the restaurant ratings. The second method was feature importance analysis, utilizing the random forest algorithm. The feature importance scoring ranked and visualized the importance of each predictor variable in predicting restaurant ratings. By combining the results of both analyses, the most significant factors influencing restaurant ratings were identified and were then used to build a machine learning model capable of predicting positive or negative restaurant ratings. Next, let's look at the predictive modeling and model evaluation employed in this research. For data integration, the restaurant rating dataset and delivery personnel rating dataset were merged to create a unified dataset. This dataset was then split into 80% for training the model and 20% for testing its effectiveness. Three machine learning models were selected to run the predictive modeling, namely linear regression, random forest, and gradient boosting. Several evaluation metrics were then used to assess these predictive models, such as accuracy, precision, recall, F1 score, and confusion metrics. Based on a comprehensive analysis of these metrics, the predictive model that demonstrates the superior ability to predict positive or negative restaurant ratings was then chosen as the best model. Following that, let's delve deeper into results and discussion. Based on Research Objective 1, this research examined the impact of delivery zones on restaurant ratings and user complaints. The findings are that while Delivery Zone 2 has the highest mean rating, it also exhibits the highest standard deviation, suggesting potential variation in customer satisfaction within delivery zones. Delivery Zone 3 has the most complaints, indicating a potential rise in complaints as the delivery distance increases. These findings suggest a potential relationship exists between delivery zones, restaurant ratings, and user complaints. However, the correlation analysis revealed a weak negative correlation between delivery zones and restaurant ratings. Delivery zones have a strong impact on delivery fees and delivery times. However, it is not significant enough to impact restaurant ratings. Hence, it can be concluded that delivery zones have a limited impact on restaurant ratings and the number of complaints on an online food delivery platform in Malaysia. Next, based on Research Objective 2, this research identified two key factors significantly impacting restaurant ratings. The first key factor was issue type no issue, where orders without any issues contribute to higher restaurant ratings and displayed a strong impact. This highlights the importance of a seamless customer experience. The second key factor was estimated delivery time, which was inversely correlated to restaurant ratings and displayed a moderate impact. This indicates faster deliveries lead to higher customer satisfaction, though the impact is moderate compared to avoiding issues altogether. Other variables analyzed in this research were deemed as non-key factors, such as delivery fees, delivery issues and restaurant issues, delivery zones and rider satisfaction ratings, due to their low importance scoring and a weak impact on restaurant ratings, indicating they play a lesser role compared to the absence of issues and timely delivery. Thus, the key takeaway here is issue type no issue and estimated delivery time are the key factors significantly influencing restaurant ratings on Malaysian online food delivery platforms. Moving on to Research Objective 3, this research successfully managed to build a suitable predictive model for restaurant ratings on an online food delivery platform in Malaysia. Leveraging the key factors identified in Research Objective 2, which were issue type no issue and estimated delivery time, a machine learning model was built to predict positive or negative restaurant ratings. The model goes a step further by incorporating issue type restaurant issue and issue type delivery issue, even though their direct impact on restaurant ratings was weaker. This allows for a more comprehensive understanding of customer sentiment, since the repeated occurrence of these issues can significantly impact customer satisfaction. Both random forest and gradient boosting models achieved impressive accuracy of 95%, with 90% precision and 100% recall, and F1 score of 95% for identifying positive ratings. However, the random forest model was chosen as the best model to predict whether a restaurant rating will be positive or negative due to its robust performance and interpretability, making it ideal for customer satisfaction analysis. Now, let's go through some recommendations for online food delivery platforms in Malaysia based on the findings of this research. First, provide faster deliveries by optimizing rider routes, incentivizing riders, and providing customers with real-time updates. Second, embrace choice and transparency by offering tiered pricing and ensuring clear communication with customers throughout the delivery process. Lastly, utilize data-driven approach by predicting issues, personalizing offers, and forging partnerships with restaurants for optimal service. In conclusion, this research has proven that delivery zones matter less than expected. Online food delivery platforms should focus on avoiding all types of issues and ensuring timely deliveries. And also, the random forest model is capable of accurately predicting restaurant ratings. Based on these findings, online food delivery platforms can optimize operations, resolve issues quickly, and gain a competitive edge using data-driven insights. This research paves the way for exploring evolving customer preferences and emerging technologies for a seamless online food delivery experience. Thank you.